Hi, I'm Sophie, you're watching Science of It, and this is the second part of a two-part challenge video. So if you didn't see the first part, there's a link in the description, so let's go and find out the science of it.
Take a piece of string and a glass of water with ice cubes in it, and see if you can lift out the ice cubes using the bit of string. So you might have found that when you took your piece of string, it was really hard to pick up the ice cubes. They just wouldn't stick to it. So what you'll need is some table salt. Sprinkle this over the top of the ice cubes, then lay the string over the top. Leave this for a couple of minutes, and then you'll find that you will be able to pick up the ice cubes. So what's happening? Putting salt on top of the ice cubes actually melts the top layer of ice. So when you put the string on top of this, the water actually refreezes on top of the string, so it lets you pick up the ice cubes. For the second challenge, you had to design and build a structure or a parachute that would protect an egg when you dropped it from a window.
Okay, it's a bit windy, and we're aiming for that target, but we'll see how it goes. 3, 2, 1, go! Ready? 3, 2, 1. Oh wow! That was really good. I mean, we nearly hit the target.
In order for an object to be lifted vertically upwards, work has to be done against gravity pulling the object downwards, and this work is then stored as gravitational potential energy. So before we drop the egg, it has a lot of gravitational potential energy. The higher the egg, the more potential energy it has. As the egg falls, this is converted into kinetic energy, or movement. The force of gravity pulls the egg towards the ground, but the parachute can help slow the impact speed, protecting the egg. When you drop the egg, the large surface area creates a drag force, or air resistance. The more air resistance you have, the more the falling egg will slow down. So if you have a larger surface area of parachute, the egg should slow down more.
Is our egg intact? It's alive!
For this challenge, all you have to do is get the fork and the spoon to balance on the edge of the match, on the edge of the glass. So we can balance the fork, the spoon and the match like this because their centre of mass, or average of all their masses put together, is in a certain place. Since the object's centre of mass is already below the balance point, it's hard for the objects to fall over this. So we can balance the fork, the spoon and the match on the edge of the glass. Now you know how it works, why not challenge your friends?
Which way is this? Oh wait, no, I think I'm cheating. I think the balance. Wait, I think I've got it. Have I got it? No. Okay, I think I got it. Okay, I think that's enough of the spooning fork.
Well, we got it on video.
And now
Well, you got me jumping, going no.
But what about the bonus challenge? I was playing around with this setup, as you do, and I noticed that when I turned the glass, the objects would keep moving, then return to the same position.
why do you think it does that?
Gravity.
Surfaces are balanced, so it stays.
What if Newton's laws or something? Maybe I'm not really sure.
This is because I'm applying a force, which gives the objects an angular acceleration. But when I remove the force, the angular velocity decreases, as there's friction between the match and the glass, which causes it to decelerate.
So for this challenge I used a 250ml glass bottle because it was the only one I had. The science still works the same way, but ideally you want a 1 litre glass bottle. It just works better.
So when the egg's just sitting on top of the bottle, the air pressure is roughly the same inside as it is outside. So to get the egg inside the bottle, we want to decrease the pressure inside as gases move from areas of high pressure to low pressure. We can do this using a match. Light the match and put it in the bottle, then put the egg on top. The heat from the match excites the air particles inside the bottle, and some of these get out around the egg. Air is also used in combustion, and both of these together lower the pressure inside the bottle, so you can see the egg starts to move downwards. So this would have worked if I'd had a bigger bottle. But you can get the egg out if you actually blow on the mouth of the bottle, because this increases the pressure inside the bottle again, so the egg should come out. I didn't try this because the egg wasn't exactly intact.
If I have this cotton reel and the string is underneath it and I pull the string, which way do you think it will go?
Well, the thing's gonna try and move that way, but because you're pulling it, it's gonna stay the same.
Oh, it's like a yo-yo. Hang on a minute. If you pull the
Yeah.
string.
No?
Oh wait. If you pull the string, it's gonna go forwards. It's gonna go away from you.
Yeah, it's gonna move that way, but because you're pulling it, will it not?
No, I think if you were holding upright, but I think it will go away from the string.
Away from where you're pulling it.
Yeah.
Yeah, it'll try and go that way.
So if I pull the string in the forwards direction, do you think the cotton reel will roll forwards, backwards, or not move at all?
Maybe.
If you're pulling it this way, you're exerting a force on it this way.
No, the other way.
So
That way. That's the way. I expected to go that way.
I have no idea.
right, let's try this. I'm gonna move the fork. Okay. So I've got the string. I'm gonna pull it.
Oh well, I failed that experiment.
It's kind of isn't it?
I should really know that. That's like a yo-yo. Oh well, fine.
So the force you're exerting on the cotton reel is acting near the centre, which makes it turn clockwise. But there's also a friction force between the bottom of the cotton reel and the floor. So this makes the cotton reel turn anti-clockwise. And this is a stronger force than the one you're exerting. So the cotton reel rolls forwards.
It's kind of counterintuitive, but it sort of makes sense at the same time. Because you're pulling it in this direction with a force. So the net force will be acting in this direction. So you would probably expect it to go that way. But then our intuition tells us that it's going to roll the other way.
We're used to seeing things like the cotton reel roll backwards in the opposite direction, because the string is usually closer to the floor. You can think of this like a column standing on its end. If you pull from the middle, it's going to move towards the way you're pulling it, just like the cotton reel. But if you pull it from the bottom, it's going to move away from you.
We can actually see this happen if we pull it up the way.
Or go upwards.
Upward. Well, the string's going to move as well. Oh yeah. So forwards, backwards, up. Can't really go down.
Down. It'll fall.
Yeah, just like off the table.
I'm going to go down.
Down.
So when you pull the string upwards, you're creating an unbalanced torque, which causes an angular acceleration in a clockwise direction. And since the cotton reel is in contact with the ground, this means it moves backwards.
Oh. I said that at the start. I said that way. So now you know the science of it. If you'd like to see more challenge videos, let me know in the comments, and I'll see you next time. But I got my feet in the video. It's okay.